Welcome guys. Now welcome to my algebraic geometry video. And in this video, let's talk about what? Let's talk about the global section. Okay. So we're gonna do since we're gonna be talking about a module, right? The module on the skin, right? So we will talk about global section. And the most important fact about a global section is that what we're gonna prove is that the global section is depth exact. Okay. So let me just so you know what. So basically somebody give you the shift exact sequence, the whatever, and let's say this. And so when so this is right, OX is a ring space. And these are FGH are shift of modules, a shift of OX module. And for when I say exact, I mean that each stocks is exact, right? So this OX module, right? So each stocks basically for each small x, they are exact. Okay. And so we are going to say the global section is depth exact. So basically it means that for any u open, that we always have 0 fu, g of u, h of u. Okay, so this is left for every open. Okay. And for this, that you can immediately get another guy, which is the left exact called push forward is left exact. This is also important. Okay. So let me just quickly recall what push forward means. So push forward means that if you have x from y, this is the ring space, this is also ring space. And you have topological space. This is a map from topological space. And then let's say you have f is a shift on x. Shift on x. And then we can push forward this f, right? So when we push forward this f push forward f will be the shift on y. So the natural definition is that I need to take an open set of y, and the easy definition is that I do the inverse, right? Because continuous continuous inverse of open set will be open, so it's f inverse u. Okay, so this is the same as global section, right? Because this is just some global section. Okay, so which we immediately give us that if we have the exact sequence on x, then we immediately have the push forward is left exact. Okay. Okay, so we proved, so we immediately prove that global sections. If we prove global sections depth exact, then it proves prove that push forward is depth exact. And there's a comparison that in the future that I will prove that there's a guy called pullback. So pullback is the exact function. Okay, so this video I only prove the global section. It's depth exact. Okay, this proof is just check your understanding of the shift, right? If you understand definition, then you should be able to prove it. Should not be difficult. Okay, so let's prove. So let's prove this. Let's write down some definition. Okay, so let's call this phi and let's use phi prime or maybe phi. Okay. So the first one is very simple, right? So the first one is let's prove that phi prime is injective. Phi prime is injective on stocks, right? So we need to prove that phi prime is injective on global section on any open set U. Okay, but this is just shift property, so this is simple. The quick way to prove is that I usually the way I like is that you use there's a injective map from f to the u to the product of x belongs to u and fx, right? So this mapping is injective, and we also have g of u. Okay, so this map is injective, and we have the map, and we have the map. Okay, and this map is injective because each small part is injective. So we have 3 injective, and this diagram commute by this diagram commutes, right, by definition of the shift. So this guy must be injective because these 3 of them are injective. Okay, so we prove that phi prime is injective. So this proves that we at least have this. Okay. Now we're going to show the exactness of this part. Okay, so the exactness. Okay, so in order to show this, let's say I write F G U U U and phi prime. Sorry, I use phi prime phi. So let me just Okay, so now we first, all right, in order to prove this, we need to show that the image is the same as kernel. Okay, so we need to show that image. Is it correct? Yeah, image the same as kernel. Okay, so obviously that that's okay. So from here, right? So each stocks, right? So let's say, since stocks are exact, right? So we know that each stocks are exact. So we know that right, phi will induce a stocks, induce a map from stocks, right? So it tell you that if I do phi and composite with phi prime and take on stocks, then I will get phi prime xx, right? So if I choose a global section on S, right? If I choose S belongs to G of U. Sorry, it's not the same as this, right? If I choose the S belongs to F of U, and I take this and take S, right? Then I should get 0, right? Because for all X. So, but this tell you that this phi map on, since our each stocks is 0, right? So this guy must be 0, right? Because if each stocks are 0, the injectivity of will give you this. Okay, so this tell you that image, we got an easy direction. We get the image of phi prime is in the kernel of phi. Right, basically it's an image of phi prime u is in the kernel of phi u. Like if we restrict it to each, so I should write as this. So for each is we always have this, right? Because each stocks map to 0. Okay, so we got the easy directions. Okay, so what's the next? The next one is a tricky one, right? Tricky one. Okay, so we need to prove this. Okay, so that's our goal is to prove this. Our goal is to prove this. Okay, so we need to, so let's say this is the proof, a little bit tricky. So let's take T to be kernel phi. And so what we got? So we got phi of, let's say I did for phi of U, right? For phi of U is an open map. It's a restricted phi of U defined to be F, the middle one. So it's, yeah, so G of U to H of U. Right, so let's say map to 0, so T is 0. Okay, then by definition, what? So okay, so we have this, right? But we know, right, from exactness, right? So if, okay, so let's say if we restricted this phi of U to each stocks, right? If we restricted this phi of U on each stocks, we get phi of U T, right? Restricted on each stock is 0, right, for every X, right? Because, right, 0 restricted to 0, and for each restricted 0, then will be the exactness, right? So there will be some image of phi prime of U of X. Sorry, phi prime of, yeah, well, phi prime of something, right? So for each X, there will be some guy here. Let's call it S. Let's give a name, right? Let's call it S X prime. So XS prime is the element in the when we do a restriction. Okay, so it's band notation, but so it's belongs to the f of x, right? Some fx. Okay, so on each stocks. Okay, so that means that by the stocks definition, there will be a representative, right? So there is a small open set U. So let's write right, so the U. So you have like S X prime, and let's say V of, let's call it V of X. Okay, and yeah, so such that we know that phi of restricted phi x, right, in it's called right. So we have this, right. So now we get this. So we have phi prime, right? So phi prime of x is prime, right? This guy is stocks induced the global one induced on stocks, right? This guy act on our x prime will give you the t. That's called this. That's the called t, and the t restricted to each x. That's called tx. Okay. Okay. So by for every x. So this is just bad notation, but this I just want to say that on each stocks, right? So if you restricted this t to each small stocks t of x, then by the exactness, that you will get something which is phi prime of x prime equals to t of x by the exactness. Okay, so this is true from each t. Okay, so the next that we need to use is the gluing property, right? So let's say, and so this is exist on this small inter, this guy. Okay. But this just basically this sentence just tell you that phi of that, because now we can choose the very small region such that, so we get phi prime of x prime is equals to tx on v of x. Okay, so we have this. So on very small each point, I have a very small interval such that a small open set such that this is true. Okay, so now we just check the gluing property. Okay, so let's check. Okay, so we check that if we do like phi prime and the vx intersection of vy, and right, we do this. Right, and then we check that if I restrict it from x prime, restrict it on v of x intersection of vy, this is the same as what? This is the t of x, right? But restricting to v of y, right, by the Shiver property. So it's v of x inter v of y. Okay. And then this is also the same as phi prime if you exchange x and y. But because now basically you are saying the same thing, right? Because now if phi prime x prime is tx, then you reach on vx, and then when you do the overlapping, when you do it, it will become the same tx restricted to the small guy. Okay. So now by Shiver property, or by gluing property, that there's a guy, right? There's a okay. So now let's do a little bit slower. So now this is true, right? But we know that phi prime is injective. I think this is what we previously proved, right? Phi prime is injective. So this tells you that this sx prime v of x. So now on each x there is a global the restricting is the same. Okay, so by the gluing property, there is an s belongs to the middle one, right? Okay, sorry, belongs to f of u, such that when s restricted to v of x will become xs prime. Okay, so the rest is just we need to show that the f of u phi prime of u, right, this guy x on s, right, will give you the t. Okay, so this is what we're going to show, and it's very simple, right? The reason is that if you act this phi of u and you act on this s but restricted it to v of x, then by definition they will become what? By definition, you will the same as you do, right? You restricted this into xs prime, right? So this is the same as you do like phi of x xs prime, right? And this guy will give you the t of x. Okay, and you'll do overlapping still the same. Okay, so that means that this guy is a sheaf, right? It restricted to any v of x become a t of x. Okay, so this tells you that for every x, right? So this tells you that they agree on all the open sets. So this means that phi of u of phi prime of u of s is the same as t. Okay. So now we use basically we use twice the gluing property. The first one is that we use the gluing property on this part. this part. And then the next is that we use gluing property on this part. And then the middle one need to use the injectivity of phi prime. Okay. So which we prove that there is a t such that your phi prime u of s is the same as t. Okay, so this proves that if t belongs to kernel, there's a will become an image of phi prime, which proves the left exactness of the push forward and the global section. Okay, so I think next time we can start to do some the results about tell you something about coherent shift and something that kind of thing. See you guys next videos.